All right, Len, thank you again, man. So we've seen modulo. And I know that I can write a lambda that looks like this. And do if x modulo 2 equals 0. And this will return true or false, because this just does a comparison if the number is divisible by 2. And let's go ahead and just print this out and see what we get. So we see this looks like it's working. 0 is divisible by everything, so it's 2. 1 isn't divisible by 2. 2 is, 3 isn't, 4 is. So we have our is divisible by 2 lambda here. What do I want to do with this? I want to use filter. And just like map, the first argument is an iteratable, and the second argument is a list. And this it's basically a for loop. And what filter does is it puts, let me pull up our little annotator. It passes in each item in the list as an argument. The lambda has to return a Boolean. If the Boolean is true, filter puts the thing in a new list. If it's true, it puts it in the list. If it's false, it filters it out. So fingers crossed, I got this code right, and let's go ahead and print out what we get. And it returns that map-like object, so we'll cast it to a list, and let's see how we do. And let me comment out all these print statements that we don't need. And something, let's see here. There we go. I don't know why that was hanging, but we can see that this filter function took every item in the list, ran it into our lambda is divisible by 2 functions, and the ones where the lambda returned true, it kept, and the ones where the lambda returned false, it tossed out. Len, yes, sir.
Yeah, I just think about this too. You may look at that and say, yeah, it's just 0 through 10. Of course, that's a toy problem. Who cares? A lot of times when these come into play, and we talked about this before, is like later when you have unknown information coming in continuously, and you literally just want to filter out the unwanted data and save it, right? Like you have no idea what's going to happen because the code is coming in from somewhere else in the world. Like when you start building your bigger applications. And so that's really where these become super fundamental. And that's why I was saying, like, you're going to have lots of practice in the coming weeks.
Yeah, excellent point. Excellent point. This really comes into its own when, say, you've got a bunch of user data, and or maybe you have a bunch of people that own pets, and you need to find all the pet owners that own dogs. Do folks have any questions about filter? All right, let's go ahead and let's see one more kind of cool Python-y language feature related to lists and dictionaries, and then we'll kind of dive into files and errors and stuff like that. And the last thing we're going to look at is zip for dictionaries. And this is a very useful sort of utility function. And let's just say we had a list of numbers. And let's just say we had a list of letters. And let's just say I wanted to combine these lists in some form or fashion. There's a number of ways I can do that. What zipped will do, and in fact, you can see it's giving us pretty much this same example right here, is it takes the lists that you give it and combines each thing from that list into a tuple. And then it makes a list out of those tuples. But let's run this code and see what that looks like. We're going to have to do a little casting of what zip returns, because as we'll see, it doesn't return. And let me just comment out that print statement. We can see that zip returns something of class zip, and it doesn't have a nice print statement. Just like with map and filter, the thing it returns is some sort of Python object. The term is iteratable. And in terms of iteratable, think things that can be easily turned into a list, or things that we could loop through. Or if I wanted to, the same way with that map object that Python sent back, we could go through that sort of list of tuples. And in fact, if we do it this way, note that the zipped has been emptied out when we print the tuple here. So the behavior is a little different. This doesn't have a big impact most of the time, but it is a good heads up that like when you go through each of these and turn it into something else, it seems to be pulling it out of this class, which actually I'm a bit surprised that it does that. So you've got two ways to play with your zipped stuff once you put it together. And I believe you could also, cat, dog, fish. I think you can just throw as many lists as you want in there. So that is zip, right? Super useful for when you need to do something like that. Do folks have any questions about zip? And to be honest, I'm not sure why we talk about it with dictionaries. Oh, because you can turn it into a dictionary as well. I'm so sorry. Let's see one of the best parts. I don't think this will work with 3 lists. It should work just fine with 2. This is why zip is so cool. Turns it into a dictionary for us. I think it's going to complain if we put in animals. Yeah. But 2 things is fine. So that's the power of zip. Combine lists, turn them into tuples or dictionaries. All right. Let's switch gears. We've been talking a lot about all of these Python language features, dictionaries, lists, working with data. Let's talk about errors. Errors are one of the most important parts of programming. There are all sorts of things that you might do that could produce an error. reading a file, if the file doesn't exist or is malformed, getting user input, making an HTTP request over the internet. Basically, anything where your program needs to interact with, for lack of a better term, the outside world. Because those are the things that are beyond our control. What if, just like with my laptop died, the server is down when our program makes an HTTP request over the internet? What if our program depends on a certain file existing, but the file has the wrong name by mistake? There's no way for the program to know that. So good programming involves handling potential error scenarios and deciding if the program should gracefully deal with the error and not break and keep running, or if the program should break. Because sometimes you actually want the program to break. There are certain kinds of errors where, like, this is actually, we shouldn't have the program continue because it might make stuff worse, or it's just not a good way to fix it. Other times, like a website is a great example of this. If we have a bunch of JavaScript on a website, just because maybe, the interactive map on the website has an error, I don't want that to break the whole site for everyone. Right? So it depends on the scenario. How do we do this? We do this with try except. Things that might cause an error get wrapped in a try block, and in an except block, we tell our program what to do for different kinds of errors. There are many different kinds and categories of errors, and Python has a lot of tools for dealing with the different kinds. We're just going to see the most basic stuff today. So let's write some pretty simple code just so we can have some examples here. So I'm just going to make myself a couple variables. The squiggly will go away in a bit. It's looking for accept. Pass, by the way, is something that you can put in as a placeholder in your code. It does nothing, but it does keep squigglies from causing errors because Python is expecting something to be here. Note that red squiggly down here because Python is expecting something to be in the code. So this just tells Python this is empty on purpose. It's not an error. We're going to cause an error here because we're adding a number in a string. I don't know what Python's going to do. I don't even think we're going to get to that print statement. Let's give this a shot. Let's see what this does. So this is great. I see 3, I see error. Not really selling me on it. What if we didn't have the try except block? Right? We get an error. Note that the error is on line 28. Note that we see the first print statement from line 26, but not the second, because the error is here and it fails, and we don't get to this print statement, and the program breaks. And if this is, say, a program that's supposed to be continuously running for whatever reason, this is not what we want. So when you want your program to gracefully handle an error, or you know what you want to do when an error happens, use a try except block. And for all of you, the most immediately relevant scenario for this is when you all are writing code to read files, which you all will be doing very soon. You can also use else to handle success. If I comment this out and I run this code, we'll see the else message. If I comment the error producing code back in, we don't see the success message. You can also, and I'm doing this just so we have a little more real estate, write what's called a finally block. And this happens every time. And so if we run this code, we see that rain or shine, the finally block gets executed. There is more to it than that. You can indeed you can specify different categories of errors and write multiple except blocks for different categories of errors, and then actually print out the error information. But that's a little out of scope of today. Today, I just want to introduce these core mechanics. So I just want to check in and see if folks have any questions around sort of the basic concepts here.
I have a question. Would you be able to then execute, like, say, like one example I have is like if your software needs like a GPS lock and it doesn't have GPS lock, is there some way to handle that? Like, say there's a certain amount of code you could do that to like try to reconfigure something to get that GPS lock to go? Like that's a pretty extravagant example, but like how could you handle that error within the code without your user doing anything?
Yeah, great question. Let's actually dive just a little bit more into it, and then we will switch gears. Let's write a function. Let's call it attempt GPS lock. I'm going to get a little help here to make sure I get this syntax right. So there's different kinds of errors. We probably wouldn't want to raise a value error. There's type error, but value error is relatively common where there's an argument value of the wrong type. In reality, GPS lock is probably some other kind of error, but let's just pretend this is what happens. The term raise means create, raise an error, and raise, what happens is if an error is raised within this try block, it's caught by it and handled in the except block. And you can have like sort of multiple try blocks and multiple except blocks. So now let's force our error. We know that this will fail. That's the keyword that I'm missing there. To do it this way, I need to say value error as E. Let's see what information we see. So errors are a normal part of programming. There's all sorts of valid reasons for there to be errors. You know, maybe the user has to upgrade, maybe they have to enter a code. Errors aren't necessarily like worst case scenario stuff, and they're kind of in some ways like if else statements in describe. They let us control program flow. And the scenario you raise is a great example of this, where we have some function attempting to do something that we know might fail, so we do it in the try block. And if we know what kind of error will be raised, and we do because we wrote the code, then we can write an except block to handle that particular situation. Yeah, great question.
So just to clarify, so in that except block, instead of, that's where you put the code to actually try to troubleshoot that error.
Correct. Depending on, do whatever we should do when attempt GPS lock fails because of a value error. Right? Maybe we need to display a message to the user. Maybe we need to try an alternate. Maybe we need to shut down. Maybe we need to do something else. It just depends on the nature of the program. Does that answer your question?
Yes, thank you.
Yeah, great question. Love it. Love it. So for all of you, reading files is when this is going to become relevant. So just file that away. No pun intended. Let's talk a little bit about importing and exporting in Python. So I've just created a new directory where I'm just going to put this stuff just for clarity's sake. And there's two files in it, awesome utils, awesome utilities, and runner.py. Runner.py, this is our main method that runs the code. Awesome utils py, this is holds a bunch of related functions and data. And let's in fact rename this to something a bit better. Because we're going to write some code for saying hello and stuff, and we want our file names to be useful. So we'll call this greeter.py. And let's write some greeter methods. Let's write maybe like a custom method. And then maybe, in fact, we want a list of or a dictionary of custom, reading messages. happy Friday. And how about, oh, happy birthday. And I'm doing this in part just to give us some examples. There's not, and there are multiple ways to write this code, all of which are valid. I could have named this like this. But you know, I was saying the other day, if you have data that's never going to change, the convention is to do it in all caps. And so that's what I'm doing here. But the name is irrelevant. Good news is that in Python, importing is relatively easy, especially if two things are in the same directory. Well, that doesn't quite seem to work. What if we do greeter.say hello? Well, now that red squiggly goes away. Let's see if that code actually runs. So that's pretty cool, right? What happens is every file in Python is a Python module. And Python does this for us. This is how the language is built. And we don't have to export anything in particular the way we did with JavaScript. Anything at the top level here like this is part of the module. And you can think of a module as one big object, more or less. And I know we haven't talked a lot about objects, but note the dot notation that we've seen in other places. And in fact, if we print the type of greeter, we'll see something interesting. That there's a module class in Python. So Python has done a lot of this work for us. I can do not just functions, but anything, any top level variable in that module is available. So, you know, I could also, if I want to, I could do greeter dot custom greeting Alice greeter dot custom greeting messages happy birth. And I just want to pause to check in and see what questions folks have, because we're going to look at a couple variations on this, and I want to make sure that we feel good about these fundamentals. Len, yes, sir.
Yeah, feel good to the idea, because all next week we're gonna dig more into this. So I feel like I'm not really sure what's going on. Like all next week is really going to be a better understanding of what the hell is that dot doing and how can I do all these things. Like that is really the OOP week is getting your head wrapped around that. So it's feeling good about, yeah, it's not mud. It's a little clear.
Good point. Good point. Very good point. Tristan, yes, sir.
I was just wanting to ask. I was looking at the schedule and it said that this weekend is 3-day weekend or somewhat. Is it that there was no
correct.
class on Monday? So
I
would you
believe
just
that's
recommend
correct.
that the entirety of that time just get down Python and all of this and kind of just make sure we get general idea of it before Tuesday?
Great question. I recommend you all spend as much time as you can this weekend first finishing the coding assignments from today, right? That's job one. Once those are done, don't like polish and perfect them. Watch the lesson videos for like the first lesson next week, or read it in the curriculum and do those assignments. If you can, get like a day ahead. Even better, get 2. Because the goal is, even if you're like, I feel like I'm at like 35% understanding, you know, there's a lot of information coming at you. It's a fire hose, I know. So I think seeing it in advance, and even better, a little bit of writing the code, because it's really that hands-on keyboard time is how you internalize and learn it and get it under your fingers, so that when we're in class, you're able to like absorb that much more and kind of go that much deeper in your understandings and work on the assignments.
Okay.
Yeah, 1000%. Jacob, yes, sir.
So did you in Greeter, did you have to put something at the top to connect
Nope.
it to runner? Oh, you
Nope.
didn't? Because I was trying to go along with you, and for some reason I'm getting an error where it says import greeter could not be resolved on my runner. I'm not sure.
So
Not
it's
sure.
hard to debug stuff like that without looking at your command line. But
Yeah.
short answer is I would make sure they're both in the same directory.
Okay.
Yeah. That's the simplest and easiest possible solution. I would double check the file names. Basically, I don't know why this PyCache thing got created. Basically, you can see right here, we don't need this PyCache thing. Let me delete it. All that matters is that because import statements do have a path. We're going to talk about file paths in a minute.
Right.
The fact that this just says greeter the way it is, and there's no path, there's no like slash anything, that this code is assuming what happens when I do Python is going to look in the same directory that I run this command from. That actually raises a good point. Make sure you are running this command in the same directory where runner.py is, which is also where greeter.py is.
Gotcha.
When I run that command, Python, when it sees line 8, we don't have a virtual environment, which is a different story. So it starts looking for a file named greeter. And then it reads this Python code and bundles it up into a module, and we get it like this.
Gotcha.
Yeah,
Okay.
great question.
Thank you.
Owen, yes, sir.
Yeah, for the formatting with your like greeter.py and runner.py, is that just always going to be used, or is there going to be some cases where it's like, well, we don't really need a greeter.py because we're not going to be running this. I don't know. It's going to be running in the background, for example.
Do you mean the file names or something else? I just want to make sure I'm
Yeah, like
understanding.
the file names where you have like your greeter, your runner, and then there's one more. I can't remember. It was like the
Got it. Good question. So a couple pieces to that puzzle. The .py file extension is for us humans to recognize this is a Python file. The Python interpreter, the Python runtime, doesn't care.
Yeah,
just
I
to
got
build on it real quick, the name runner, and I think this might be what you were asking about. There are different conventions. In JavaScript, you'll see it app.js, sometimes main.js, but as programs get bigger, you put relevant code in its own file. And we basically built our own little mini library here, our own little greeter module, right? And I named it greeter because the job of this code is to say hello and greet people. If it was like something to get the weather, I would have named it weather.py or whatever. So this name really just depends on what this code is doing. Runner, there are a couple conventions, but you'll see in this class, runner is like the main file that you should import your code into and then actually execute on the command line with the Python command. Is that what you were wondering about, or did I misunderstand?
Yeah, no, you answered my question.
Awesome. Yeah, great question. For now, name all your Python files lowercase. That's the other thing. Lowercase, camel case, all your directories, lowercase, keep file name, directory stuff lowercase. Cool. Let me show some other ways to import, and then we'll look at paths, because you're going to see multiple ways to do this. And there's more than one right way to do it. So what we just saw there was one way. By the way, I could also do import greeter as my greeter, and then I would just do my greeter dot say hello. I can use a different name if I want, like an alias. More interestingly, kind of like object destructuring, if I do from greeter import these things, rather than these things living on the greeter module and being in the greeter namespace, I now just have these in the namespace of runner py in my that I can use directly like so. And this, for obvious reasons, can be very useful. And this, in fact, how the heck did we do it? Was it import p? I think it was from pprint. Import pprint was how I imported the pretty printer before. From the pretty print module, which is part of the Python standard library, it got installed somewhere, wherever our Python runtime lives. We import this function. And that's exactly what we're doing here with our own module, greeter. And let me just also then finally import, it was custom greeting was the function. And so I have all this relevant code bundled and organized together. And there we go. We've got goodbye, hello, and Harry Potter, happy birthday. And I just want to check in and see what questions folks have about this other way of importing stuff. Okay, cool. Let's talk a little bit about file paths, because this is pretty important. And then I think we'll be at a good time for a break. And I realize it's been a long day. We did not get to have the hands-on time that I hoped, but I think we've been moving at a good flow. And we'll have enough time to properly look at testing. But this file path stuff is really important. So actually, let me check in with folks. Do we want to charge ahead or take a short break and then talk about file paths?
Charge ahead.
Yeah,
Charge ahead. Okay. Because this is probably the biggest pain point for people and the easiest thing to make mistakes with. So I think it's useful to make sure like we're sharp. So I just want to kind of check in. All right, we're charging ahead. Let's do it. So, file paths. If I type print working directory on the command line, I see here a path. It starts with that slash, the root directory of the whole file system, going all the way to the current directory. Inside the current directory are those two files in that annoying Pytest directory. If I navigate, change directory to the root directory, this is the root directory of the whole file system. That is way too much. Let's see if we can scroll up to something reasonable. Not even. I'll try to kill it sooner.
I'm gonna say it one more time though, understand the concept here. Don't try and understand exactly what's all on the screen. That's not the
Yeah.
purpose of this exercise.
I'm doing a terrible job of showing the tree, but the point is that our file system is actually a tree. A tree data structure, which we'll learn about later. And this one looks good. There we go. Right? And when we talk about paths, and we talk about absolute paths, we are talking about the direction from here to some file. And if I could just find my drawer, there we go. So let's say we've got index.html. Let's say I've navigated to the root file system. But let's say I want to use that ls command to see what's in the public HTML directory. / takes me, actually from the root file system, I can do about everything. So we'll do it this way. It doesn't matter. I could do ls/home/Jeltner/public HTML. And I could do this from anywhere on the computer. And because it's an absolute path, it always traces that path from the root to where I am. Like over here, ls users Adam C code Yankee demos and notes. Let's say I want to navigate to my home directory. Well, ls users Adam C code Yankee demo and notes. Right? If I start from the root of the whole file system, the absolute path, it's good everywhere. But this is a problem. And this is a problem for Python code, because if you write Python code and use an absolute path, and then I git clone your repo and run your code, what if like you're on a Windows machine with WSL and I'm on a Mac and it's different and the absolute path breaks? So absolute paths, while they're powerful, they're limited and they're brittle. A relative path, let's say, to use this example, let's say I'm over here in the home directory and I want the path from here to public.html. And I want to use the cat command to print out that file. Dot on the command line is actually a path. Dot actually represents where you are. Let me repeat that. Dot is a path. Dot represents where you are. Right? And in fact, if I just type ls and hit enter, it's the exact same as typing ls dot. Dot represents where you are. And ls dot represents a level up. If I'm over here, dot takes me up there, right? If I'm over here, dot takes me there. If I'm over here, dot takes me up there. Dot is a level up. So if I do ls /, I hit tab to see what's here. I'm looking at my home directory. CD dot dot takes me a level up to my home directory. If I want to go deeper from where I am, which is the dot, I do slash. And then I can choose where I want to go next. And that's a relative path. This dot slash is a relative path from where I currently am, right? And the challenge is if I say navigate to the root directory of the file system now, and I run this command, it's not going to work because I'm in the wrong spot. Len, yes, sir.
So just to add, this is where you don't want to be a spelling champion and remember the whole path. Tab is your friend. So if you know where you want to go, for instance, Adam started where he was, hit the dot, / saying I'm going to go into some directory or file underneath this one, typed a Y and then hit tab and it would autofill in. If there was something else that was called like Yankee _ demos 2, it would stop at the S and he had to go to the next character and you get tab again. Does this make sense? Am I? And this is where tab, it's super helpful. Tab, don't be a spelling champion. Use tab.
Love it. What other questions do folks have about absolute and relative paths? We feeling relatively comfortable? Cool. So the other thing to know that's important is often like when we talk about a file name, we're also really talking about the file path. Because right now, let me go to like our demos and notes repo. So let's say I want to open one of these files in VS Code. I don't need the / at the beginning of my path on the command line, but when we're putting stuff in Python, sometimes we do. Those two things are the same. And we're going to go in here and let's open up just foo.py, which has nothing in it. So all these commands, right? Because you've seen me do code foo.py, which works great when I'm in the same directory, when my current working directory on the terminal, is the same as where this file lives. But when it's not, I just give my program the path to the file. And this is going to be exactly how we do it in our Python code. And let's close out foo.py because we don't need it. And let me go into our directory where we are, because it is going to matter. So there's two things you got to think about for file paths and reading from files. There are two important things. What directory am I running my Python program from? What directories are the files I need to read or import in? Why? Because where I'm running code to where file we import lives is the relative path we need. So the simplest way to do it is always run your code from the same directory where runner py is, and you kind of organize everything around that. So let me make a couple files that we can play with to see this in action. And before we do that, let's see how we interact with paths in our Python code. So let me comment out all of the greeters. and let's see how we deal with paths in Python. We need to import something from the Python standard library called OS, short for operating system. And as you can see, this is going to do all sorts of path stuff for us. The current working directory is where this program is being run from. Let's see if we hover over this, if VS Code gives us a nice description. They don't, but we'll just run it. Notice that this is an absolute path. If I navigate back a couple directories, and let me see what I need to do here. Python for import, export, runner py. Notice that the current directory is not where runner py lives. It's where I'm running this command from. You guys see what I'm saying? What's changed right over here? So that is a really easy point of confusion. The best way to solve it is just make sure you're always in, for now, the same directory as runner py when you run it. Because this path changes depending on where we run it. So that's the best way to keep it simple. We can also get an absolute path for a particular file if we do stuff like this, abs path to CUD OS, and let's print that out. So dot remembers where we currently are. Let's see what I did wrong here. I think I would just have OS dot path, excuse me. And in fact, we can see here, we have a whole bunch of path related things that we can do. I'm not sure if it has a relative path. Okay. Maybe the absolute path, not to where we are, but a level up in the file system. Maybe not the absolute path to where we are, but maybe the absolute path to some other file, a level up in the file system. Maybe a file that I want to import. So there are tools for grabbing the absolute path, but they all work relative from where I'm running the program. So what this is leading up to is importing. So we import with a relative path, and we use a command with, and we use the command open. And I give a string that points to the file with a relative path. Even if an absolute path works, you don't want to use it because, again, if I am running your code, or if, say, the automated tests on the cloud and GitHub are running your code, the absolute path will break stuff. The second argument R is for read. We're telling Python we're only going to read this file, not write to it. And like many things Python, it lets us turn it into some sort of list-like thing. We'll learn more about dealing with comma-separated values and manipulating this stuff later. I just want to show the basics of opening the file now. So you can use an absolute path here if you need to, but you shouldn't. But maybe what you need to do, sometimes maybe you need to do something like this. Right? Maybe for whatever reason, this is how you need to write your code. This will work as well. Though that's actually wrong because I wanted to point to example.txt. That was actually our examples py source code that it got. So it actually did its job. It was just the wrong file. But most of the time, you want the relative path. I think I'll leave this here as a full example. I'll just comment it out. You want to use a relative path. So this is a good pause point. So I've been talking a lot. So let me just check in and see what questions folks have, and then we'll take a break and then we'll look at tests. What questions do folks have? Okay. We feel like we're relatively comfortable with using a relative path here and the difference between relative and absolute paths. Comfortable enough to know what questions to ask if we get stuck.
Yes.
I'll take it.
Okay.
I'll take it. Yeah. And practice is the key here. The other key is just on the command line, just type pwd all the time, type ls all the time. Another useful thing to know is in the Explorer here, if you right click on a file and you go to open an integrated terminal, it will open a new shell session where the working directory is exactly where that file is. And that's very useful. All right, why don't we take, are we good with 10? Let's take 10 and then we'll look at testing in Python. All right, folks, thank you very much. Take 10 minutes and we'll wrap up the day with a good dive into testing. I know it's been a big day. I really appreciate it. I hope this overview is useful and we are in the home stretch. Get off the screen and I will see you all in 10 minutes. Cool. All right, let's talk about testing. And is this font size okay? Or do I need to bump it up? Okay, awesome. Testing. We've talked about it a little bit. There's a whole philosophy. There's whole schools of thought around testing. One is called test-driven development, TDD. We're not going to go super hard on it, but there are a lot of workplaces where like this is the way you write code and this is your workflow. It's not quite as trendy as it was maybe a couple years ago, but it's still around. And it offers a couple really valuable things, I think, especially for beginners and junior software engineers. So let's talk about what is it, why it matters, how you do it, and then we'll see the tests. We're not going to do a ton of TDD today, but I want to introduce it to you so it's in the back of your head as you write code. So TDD is it's a workflow, right? If measured twice, cut once is a workflow. If, draw the blueprint before you build it is a workflow. It's a checklist. And the goal is to reduce errors and bugs and improve workflow and productivity. Like all new workflows, it takes some time to learn. The core concept is red, green, refactor. Red, write a failing test for a tiny bit of functionality you want in the code, like say a function you are working on. Green, write the minimum amount of code you need to bring that bit of code to life for it to pass the test. Refactor, once the test passes, refactor, rewrite without changing what it does to improve its structure, readability, etc., while keeping the test passing. So it's a little weird to build up the habit, but if you do, it reduces bugs, it helps you chunk work into tiny bits. Why TDD matters for your job, for teams, for orgs. Reliability. Tests are one way to ensure code reliability, which reduces bugs. Documentation. Tests are living documentation. If the code changes, the test breaks. So if we update the test, we know it's current. If I just have a whole bunch of markdown or comments, well, those have their place. If I change the code and don't change that because I'm busy, then, you know, we don't know. Collaboration. Tests make it easier to change code. They give you a safety harness or test harness, which makes it easier for multiple people to be changing code. Because what if we're collaborating and I'm working on my code in one file, but I change something that doesn't break my code, but it breaks code that you're working on, but I don't even know. And then I push that code to GitHub. Well, if we have a test suite, then when I did that, a test would fail. That would tell me I broke a different part of the program. So, and then finally, what's called regression testing, which is pretty much what I was just talking about, ensuring that new changes don't break features. So we don't force you to do TDD, but the graded weekend assessment projects you work on all kind of embrace that spirit. You should do them by working on one test at a time. And it's a little weird. You probably can't dive right into it with the coding assignments, but keep it in the back of your head. And as you've noticed, I do a lot of print statements. You can do informal testing as you go by writing lots of print statements and running your code all the time. All right, so let's go ahead and actually write some tests. Len, yes, sir.
Just real quick. So I did not understand the whole test thing until we were well into Python, and that was just I couldn't wrap my head around it. But going test by test is something that I did do because I was trying to understand it, and it really helped in learning what was going on. So like I'm just gonna reiterate that from Adam and as a student when I was taking it, look at a test, try to understand what the test is asking for, what's its goal, make it happen, move on to the next test. What's it asking? What's it looking for? Make it happen, move on to the next test. Way better than just randomly saying, I'm going to try and make this thing happen without looking at anything. And you get the feel for what TDD is.
Yeah, excellent point. I love it. I love it. And actually, let me just tack onto that and say, understanding a test means reading code and understanding what it does. Reading code is harder than writing code. Reading code is harder than writing code. That's the skill to really practice. You'll do it by writing code, but tests give you an opportunity to read code and figure out the code that you're writing. Let's write some tests and let's see these mechanics, because I want to make sure we cover what we need to for today. But the philosophy and the workflow of this is a very deep topic and something that you guys will get lots of practice on. So I've created a separate directory for this, intro to Pytest. That PyCache file we can ignore, but there's main.py where we're going to write some code. There's test main where we're going to write our tests. And then there's some directory which has a greeter py file in it where I just have a say hello, because I also want to show how to do imports from other directories. And we'll do that when we write these tests. So, and let me do a quick split here. Using Pytest. Using Pytest. Make sure your Python virtual environment is activated. There's two ways to tell. Do you see default in the command prompt from installfest? The other way is a little harder, but if you type echo path, you would see here in this giant thing of paths, a file path pointing to your virtual environment directory. I do not have my virtual environment activated right now. If you need to, you can activate it with, oh man, I think that would be it. With that command, which should look a little familiar from installfest. Windows folks, I know you'll need to do this because we didn't get it in the bash script. So I'm just going to go ahead and do this now. And I'm telling this source program to read a shell script file from my home directory in the default directory, which is the virtual environment directory we created. And the shell script is named activate, which turns on the Python virtual environment. Once I've done that, we install Pytest. With npm, stuff got installed right in the directory where we ran npm install. We saw it in node modules. Python virtual environments are different. The word is too fancy. It's just a directory somewhere else that Python knows to look. And if I look at this path variable, it's a little hard to see, but at the beginning of it now is default/bin. And that's how the shell knows to find the Python stuff there. So it's already been installed for me. It is installed actually inside that default directory, but because my virtual environment is activated, when I run my Python code, it knows to go find it there. And I can go ahead and write Pytest. It doesn't do much. As you can see, we haven't written any tests yet, but that shows me that it works. So let's write a little code. Let's just test that Pytest works. So I have this test file, and I'm going to import Pytest. And I have this squiggly. When you see this message, import cannot be resolved for stuff like Pytest or things you've installed, it probably means VS Code doesn't know you're using the Python virtual environments. We need this command Python select interpreter. And then I need to find, I don't know why it's having such a hard time. You guys won't have to do this. I don't know why mine is like this, so don't don't worry about this step. Hopefully you won't have to do it.
This will become second nature as you open up, from my experience, open up
Yeah.
Visual Studio Code, close it. This is a big, like, again, absorb what he's seeing here. Don't memorize it. It will become second nature in about 2 weeks because you'll just have to interact with it so much. That's yeah.
Yeah, I have to do something a little different to fix my squiggly, and it's a little bit of a rabbit hole, so I'm not even going to worry about it. Let's just do Pytest and then the name of our test file. So I do have to give it the test file name. And this is a good start. It runs. We collected one item. I see that test Pytest works. If I change true to false, we should get an error. And indeed we do. Right? So we had expect and the describe blocks and test with Node.js and jest. And here, like with all things Python, the syntax is simpler. We can just say assert, true, double equals something else. There's a lot more that we'll add to it, but this is a good starting point. So now that I've gone ahead and done this, let's write just a little bit of code. Let's write just a simple method to add two numbers together. Right, looks good. I know, I guess I'm not really properly practicing TDD here, and for now, that's okay. So again, really simple with Pytests. Each individual test is a function. You write different files for different groups of tests. Give your function name something useful. Start it with test. Functions should always start with a verb and then describe the function or the thing that you're testing. And I better import the method I want to test. Right? Let's cause this to fail. So that's great. And if I look at these error messages, I see actually both of these are failing. And you can see the syntax here of what's on the command line where we get a little arrow pointing to the test. In red, the part that fails, the kind of error, an assertion error. And here we see the output from the function 5 compared to what we expected it to be. So let's go ahead and get these tests passed. We'll change that one first. Now we only have the one test failing. 2 plus 3 does not equal 4. That test should indeed be failing. And now it passes just the way we want. Len, yes, sir.
I was just curious if everyone's following along or if anyone got lost in the sauce.
Yeah, great question.
If so, I would recommend Adam rewind and like go a little slower. So I'm asking that. I saw some facial expressions in the screen there, and I'm just gonna ask the question.
Good call. Much
Can you
much
open up
appreciated.
the Pytest file? Sorry, I didn't mean to jump ahead. Because mine's saying, well, I didn't make a Pytest file, so it doesn't know exactly what I'm trying to open. So I'm getting an error.
I would have to see it. There shouldn't be a Pytest file, but let's walk
Okay.
through what we do have. In the directory where I'm running my Python, I have a file named test_main.py, and I have main.py. Main.py has the function I want to test. Test_main. I import it. Import Pytest is right here. Make sure your
I guess
virtual environment is activated. Yeah, what's up, Sam?
Yeah, no, it's all good. We can move on. I think it's something with my workstation. It has to be because yeah, there's no file. It's just importing a class, right?
Import Pytest.
Or yeah, importing Pytest. It's not working, so I'll just get with someone afterwards.
Have you pip installed Pytest? Don't do it right now if you haven't, because I want to make sure virtual. Have you pip installed Pytest?
Pretty sure it did. Yeah, I just did it.
Yeah.
Okay.
But
So
it's okay. I don't
Yeah.
want to hold everyone up. That's
Fair
it.
enough.
okay. I mean, it's not going to hurt you to run this command again, if you want to. In fact, we can even better. If a virtual environment is activated, we turn it off. Then we turn on the one we created in InstallFest, and I'll put these commands in the Zoom chat. So, deactivate might throw an error message if it's not there. Source default bin activate. Pip install Pytest. Sam, is that working successfully for you now? And James, is that working for you? And Owen?
No, I have my, like, I have like the bracket, or not brackets, like the default in front of it, but when I go to pip install Pytest, gives me an-
Windows folks, you have to use pip3. We ran into that issue with the aliases, so I do apologize for not showing that earlier. Are any of you guys on Windows?
Or WSL.
No,
Okay.
I think for my issue, I think I installed pip probably in the wrong directory, like the libraries. It's just saying no such file or directory whenever I try to pip3 install Pytest. Because I
Okay,
remember, we'll figure this out later. I don't want to hold up
yeah,
class
we'll
time.
have to. I do apologize, 'cause I do want to get this sorted. What time is it?
Fine.
We'll have to come back to this later.
Should we put this on the docket for tomorrow, Adam, to make sure before the COB and make sure it gets done?
Yeah, we should put it on the docket for like yeah, like right after the team stuff.
Yeah.
Because this stuff needs to be working.
I'm tracking.
Okay. Yeah, James, Owen, anyone else running into this issue, ping Len. Len, you don't have to drive the bus, but we'll get everyone into a Zoom room and get it sorted because you guys all want to be unblocked on this. Thank you for letting me know about this issue. Keep, whenever you have system issues, like raise them ASAP, because it means that it's not possible for you to run tests. And we want to figure out what the mismatch is. So we'll come back to that. And everyone else, these same commands were gone over in InstallFest and are in the curriculum repo in GitHub as well. So I would use some of those as reference points. Mac people, when you open a new terminal, if you're not seeing, for you all, it should say default over here, I believe is what was set up with Francisco. Then either I'm making a bad assumption or something is wrong, but you should all have, every time you open a shell session, that virtual environment should already be activated. We'll figure it out tomorrow. Half the time with this stuff, it's just crossed wires and it's not actually that big a problem. How are people feeling about just this basic concept of this is how you write a test and this is how you write an assertion? Cool. So you can also write tests like test example asserting not equals. Let's just say assert 3 times 5 does not equal 11, right? We're going to assert a negative. 15 is not 11. and that one runs, and if I changed it, we'd get the error. I saw a hand up. What's up?
Oh, that might have been me. I accidentally hit the hand, so I didn't have a question.
Oh, nope, no worries. You can also do what's called assert equal. Let's for fun just test two odd numbers, and let's do assert equal, add two numbers, 3 and 3, and we're expecting that to be 6. I might have to. Let me fix that actually, because I think I have that wrong. So give me 1 sec to make sure that my syntax is right. Yeah, I apologize. That one's not right. I think we actually have a curriculum error there. That looks more like JavaScript. So let's just toss that one out for now. So you can do a lot of these assertions. You can assert string values as well. And let's in fact see what importing from another directory looks like, what that file path is. So over here, I've got some directory. Inside that is greeter.py. So if my test file lives here, I need to go a level down into some directory and then into greeter.py. And the way we do that is from the directory name dot greeter, right? And this is, we were talking about namespacing yesterday. This is a great example of namespacing. Import, say hello. And let's just write a simple test for this that says say hello should equal hi. And again, I run Pytest and I give the file name. And it looks like I did something wrong here. Let's see what we did wrong. Assert none equals hi. This is actually a good example because I made a mistake here, but we can dig into this bug. Where none equals say hello. So what that's telling me is that what actually happens when I run this code is over here is none. But I'm expecting to find my method. So what that tells me is I failed to successfully import say hello. Right? Because it's none. It shouldn't be, but it is. So let's see what we can do here to fix this. So I'm not sure if it's an issue here with my path stuff, to be honest. Because I think I have the right path. And one way to test it is let's go ahead and from some directory, reader, import say hello, and let's just run say hello right here, right? Let's test this outside the test file and see what happens. Cedric, yes, sir.
Yeah, I think the error might be happening because you're returning like a print statement, which has type none, instead of returning
Oh,
the
you are so right. Thank you so
string
much.
hi itself,
Yeah,
which is causing the issue.
yeah, 1000%. Thank you. Well, I
Yeah,
didn't mean
of
to demo
course.
that, but this is a great example of the worst kind of error, which is the error of assumption. if I run Cedric, thank you so much, man. If I run
no
these
worries.
tests, I saw none, and I jumped to the completely wrong conclusion that somehow this function must be empty, probably because it's 430. But Cedric is absolutely correct that what's happening here is Python functions by default, if you don't have a return statement, they return none. That's implicit at the end of every Python function. So let's do a little refactoring. I'll keep the print, just it's nice to have. And let's return our hello message. And let's see if my test passes now. This is also a great example of why rubber duck debugging or just asking for someone else to look at the code is so important, because after a certain point, your eyes just don't see stuff. And now we are rocking and rolling. Cedric, thank you again, sir. And we have this test passing. And say hello does indeed say hi. And we can do a little bit of a modification. Let's say we want to modify, and let's do red-green refactor. Say hello to name. Now, I know this test is going to fail, and I know I'm going to get an error because that function say hello doesn't even accept an argument. But this is sort of the red-green refactor workflow of TDD, where let's just go ahead. Let's get rid of message. Let's take in a name and let's return an F string. There's some other errors with this test that we'll have to fix, but we'll cross that bridge when we get there. This is going to break my other tests. This one doesn't work anymore. So now I kind of have to make a choice. I think what I'm going to do is set a default argument of an empty string. And I think that should cause that one test to pass. And it does, except I now have a space. So that doesn't work. So I think what we're going to do is we're just going to require a name. There's a couple tricks we could do here. I think being lazy right now is a virtue because I don't want to lose the point of the lesson. So this is me being a little lazy, but that's okay. Juan, yes, sir.
Those little arrows under the H and the P, is it showing you, is that supposed to show you where the arrow is being thrown because of or
Exactly.
something? Okay.
Exactly. So what we see here is this is the danger of testing. My test is wrong. I wrote hi Harry Potter with the lowercase letters, but over here I capitalized the H and the P. And just like you're saying, the little arrows show us the difference of where these two strings that are being compared are wrong. Len, yes, sir.
So I think it's a good point. It's not necessarily wrong because a lot of times in TDD, someone else writes the tests sometimes. And so they may have a different interpretation of what's going to happen or like what the spec is. And so two different people could write something and they both could be right depending on what was written. And they both have to come together and then correct the test or correct the code depending on what they find, right? It is a very iterative and repeated process to get on the same page.
Yeah. Yeah, there's a lot of truth to that. It's in this case, because I'm writing the test, like I constructed it incorrectly.
I hear
But
you.
you're absolutely right that when you're collaborating, like tests force you to resolve issues that you might not even have known were there. And now we should have tests passing. Just to show a couple other like assertion examples. And then there's one more thing I think I want to show. I think we should be able to do assertions like this, where we can assert if something is or isn't in a list. And if I change this to pair, that test should pass. Really, sometimes you might need multiple assertions in a test. Sometimes you might not, depending on what you're doing. So we can assert that something is or isn't in a list. We can really do any sort of assertion that produces a Boolean. Because over here, I could assert 7 is less than 20, right? Let's make this fail so that we know the test is working. And that's how you know that a test works. Once you write it, you have to force it to fail. Because you have to make sure it fails when it should, and it passes when it should. We can do, let's see. I think those are good for the math ones. I think some string assertions, and then we're going to dive into our final topic, which is called monkey patching, which is a bit of a deeper dive. And this is a regular old Python string method that returns true or false. This is not special to Pytest. If I open up a Python REPL, I can use these methods. And so that's all we're doing here, is really showing how flexible and powerful assert is with all of these different Python methods. And a little bit of a preview of what some of these are. Right, so if we're, constructing messages to send to users, things like this might be very useful. All right. I do want to pause and check in and see what questions folks have, and then we're kind of in the home stretch where we're going to look at something a little more complex, which deals with user input and is called monkey patching. But I just want to see what's on people's minds around sort of writing tests and using assertions before we move forward. One, yes, sir.
Can you still do that X in front of the test that you want to not run like you did in JavaScript, or not for this one?
You can, but you do it a different way. Great question. Let me make sure I know the right way to do that. I believe, yeah, there's 2 ways to do it. This is probably the easiest way, is from the command line. So that's a good point. There may be another way, but this, I think, is on the command line. You have to actually add after the file 2 colons and then the name of the test. And it just runs the one. Like let's cause this to fail. Let's add an extra exclamation point. So we can see here that only that one test ran, right? Which is now failing to say added the extra exclamation point. And then if I wanted to
that's-
test some other test, say hello to name, for instance, we would do it like that. Yeah,
So
excellent point.
that's a specific one. Is there a way to exclude, like, especially if you have like a bunch of tests like you do right now, is there a way to exclude it or no? Like, let's say
I'm
I
not
wanted to
sure off the top of
exclude
my head.
test say hello. Okay.
Yeah, I think there is, I think if we do, I had to chat GPT this one, so I actually wasn't sure. I think if you add this over, it will. I don't want to. It's a little bit of a deeper door. I don't want to open right now. I'll follow up with kind of a breakdown in Slack though. Because yeah, that is useful to see. Let me talk a little bit about monkey patching because you guys are going to see a lot of this. It's going to be a little foreign today, fair warning. But we can get introduced to it so that you guys are warmed up as we do more of it. And let's see what this looks like. So we're going to get some user input. And we're just going to return that number, casting it to an integer. Right, so if I run this, what my code does is asks me for a number, and I say 5, and we're not even printing 5 right now. But I say 4 and we print 4. Simple enough, right? How do you test this? How do you test this? There are a couple ways. One way is maybe the user input happens in some other function and we pass it in as an argument to this one. Maybe I have to refactor my code because it's really easy to pass arguments to functions. We can do that in our tests without a problem. But you can't always do that. That is not always possible. So sometimes you have to fake program behavior. You have to fake input. And that's what monkey patching is. It's a term for faking something and kind of like getting under the hood. So let's see what this looks like and what it looks like in a test. So it takes a couple steps. And let me go over here and just give us a little room to work. Let me also import the get user input function. Let me do something a little bit more useful to it. Just so we know like what we should be getting. Just to make it interesting for the test. I write a function, a test function for it as normal. But I actually pass the test function definition an argument. And by convention, I name it monkey patch so that other programmers know what this is. Pytest will pass in that argument for us when we run the tests. Pytest is going to pass this in as an argument when it executes this function when it runs the test. So what I do is I'm just going to make a list of the inputs that get passed in. And it's just going to be one. And in fact, for now, it can just be one thing. And I need to configure monkey patch. I'm going to set an attribute, a configuration attribute for monkey patch, something called built-ins input, as in user input. And I actually need to give, and let's call this number, because that's what it is. I need to pass monkey patch a lambda function. It doesn't matter what argument is passed in. What I need the lambda to do is return my fake input. That's all I needed to do. So in fact, I could put number here. I could put 5 just to return 5. Let's just put number there. All that matters is that the lambda function returns the fake user input. Now, I can call that function and compare it to 5 plus 2, which should be 7. When this code gets run, Pytest will execute this function. And that's gonna, let's pull up main py over here and let's take a quick look. Main py is gonna prompt the terminal for user input right here on line 10. But when that happens, monkey patch is gonna step in because we've told it, listen for when this user input happens. And when it does, feed it the result of this lambda function. Feed it 5. And that will cause this code to continue and return 5 plus 2. So fingers crossed, I have written this right. And it looks like we do have an error. Let's see what the error is. Reading from standard in while output is captured, consider using S. So I think there's a step I must have forgotten here with the monkey patching. And I think the step, let's see, let's break this down real quick. Let's see what line this happens on in the code. And let's see if we can't track it down a bit. Reading from standard in while output is captured, consider using -s. So I think I may just have to use -s when running Pytest. I may have forgotten this. I'm actually not 100% certain. In the interests of time, and this is the final thing for today, I am actually just gonna ChatGPT this. And this is kind of what I was suspecting. So this, I am a bit less familiar with. This is a different approach that they're showing over here. Sys.standardin, the standard input that we get from the command line. But built-in input should hook into that input function. So this is like, you know, if there's two roads to get to the same destination, this is the other road. It's a bit too different of a road, and I don't want that. So let's just try the -s flag, because I think what's happening is Pytest is trying to get clever, but it's interfering with how Monkey Patch is also trying to get clever. So let's just see what happens when we do this. That's not what we want either. So I do apologize. It looks like I've run into an issue here, and let's see if this just does it. Otherwise, we'll pause because we're definitely at time for the day. So this should be 5. It gets. Oh, actually, there's 2 errors here. One is I modified this and I'm not casting to an integer, which I need to do right there. That was causing an error. That's the danger of refactoring. That's why I should have had a better, simpler test for it. So I do apologize, folks. We kind of came into the home stretch here, and I'm running into an issue, and I think just realistically, it's too late in the day to try and debug it. I suspect it's maybe how I'm running the command as opposed to the code itself, because we've used this code a lot. So let me follow up with you guys and get what the solution to this is so I can show it to you properly. Because I think if I try to debug it right now, it's not going to be useful. So I do apologize about that. We had a great explanation and breakdown what was going on. Then when we ran the code, we ran into an issue. But we got to see a lot of how test assertions work in Python, how flexible it is, and frankly nicer. And I will follow up with the correct way to write the monkey patch code. The good news is you guys are not writing a ton of tests right now. And really the important thing, I think, is when you're reading tests, when you see monkey patch, to understand what it's doing. So even though I have an error hiding in here somewhere, the general outline is correct. And what monkey patch does is fake user input, which allows us to effectively, and I wonder if the issue here is simply, did I just simply forget to add assert? Could it be that simple? Which allows us to effectively test code that requires user input or outside input. And it's definitely the end of the day because my error ratio is increasing as I write code. I was so hoping we could get this to work. We're almost there. But not quite. So I will follow up with you guys. Again, I think the main thing here is that as you're reading tests, when you see monkey patch, its job is to fake user input, and I'll follow up with the right way to do that. thank you for being patient with me here. We should definitely break. Let's kick off the stand down at let's just we'll kick it off at 5 after, so we'll take a short break so we can get off the screen. Do folks have any questions before we wrap up? Maybe around syntax, or if there's something that's been burning in your brain with regards to testing in this material that we covered. One, yes, sir.
Nothing really, just for the default path. I know for the Mac users, at least, instead of default, it's .default because it's a hidden file. That's the way we set it up. So in case of anybody still having that error, try .default. That might fix it. I put it in the Slack channel, but in case of anybody didn't see it.
Yeah, I didn't realize we made that change. That's actually a better change. Okay, yeah, if the name of the virtual environment directory is .default instead of default, yeah, same deal. Thank you. Yeah, and it really should be a dot file. Really, it should just be named .venv. But we want to kind of to get the impression across of that it's the default one that we're using. All right, let's break, folks. Get off the screen. We'll reconvene at 5 after in like 7 minutes. I know it's a shorter break, but I figure this way we have the daily feedback form and you can catch your breath a bit then, and then we can do our code demo and wrap. Does that sound good to everyone? All right, thank you, folks. I'll see you all at 5 after.